What is going on, guys? Welcome back. In this video, we're going to learn how to create professional bar chart animations in Python using Matplotlib in order to visualize real-world statistics, like, for example, the GDP per capita by country, like the one you can see here on the left, but also other things like browser market share and whatever you want to visualize. We're going to learn how to create such graphs today. So let us get right into it.
It's not a game, it's a rich thing.
Alright, so for this video, we're going to get started with an artificial example. First, we're going to make up some data in order to keep things simple and to focus on the actual animation process. Once we have done that, we're going to move on to an actual data set provided by the World Bank, which is about the GDP per capita by country. And we're going to take what we learned here with the artificial example, and we're going to apply it to a more complex real-world example. So in order to do all of this, we need to make sure that we have two libraries installed. The first one is NumPy, the second one is Matplotlib. And if you don't have those two libraries installed, you need to make sure that you have them by opening up the command line and typing pip install NumPy and pip install Matplotlib. So once you have those two libraries installed, you can import them by saying import numpy snp and import matplotlib.pyplot splt. Those are the usual aliases, so np for numpy, plt for the pyplot of matplotlib. And the example that we're going to model here, the artificial example, is going to be quite simple. You can choose whatever example you like. We're going to make up some data now here, so it doesn't really matter. But I'm going to choose the example of browser market share. So I'm going to pretend now for a second that we only have three browsers and they make up 100% of the market, which means that Chrome, Firefox, and Safari in this case are going to have 100% market share together, and then they're going to have their own market share, and we're going to visualize how this market share changes. Of course, again, just artificial data so that we can focus on the plotting, and then we're going to look at actual data. So for that, we're going to start here by saying labels equals, and we're going to define the labels to be the browser name, the browser names, and those are Chrome, Firefox, and Safari. And now we're going to make up some market shares. So we're going to say shares is actually a list of lists, and those lists inside of the shares list are essentially for each year, month, or whatever interval you choose, the individual market shares. So we can start, for example, with Chrome having 50%, Firefox having 30%, and Safari having 20%. And then we can copy this so that we have, let's say, 8 values here, 8 lists inside of the list, and we can change the values here. So from 50% to 40, staying at 40, going down to 30, going to 40 again, 30 again, 40 and 50. Then here we're going to have 30, 40, 40, 20, 30, 30, 20, 40, and then we're going to fill up the last column so that we have 1 in each row. In this case 2, in this case 1, in this case 1 as well, in this case 5 actually. Here we have now 3, here we have 4, here we have 4 as well, and here we have 1 again. So those are just some values that we make up, and we're going to have all of this inside of a NumPy array. So we're going to say np array of that list of lists, so that we have a NumPy array. And the reason we want to have a NumPy array is because when we apply an arithmetic operation onto a NumPy array, the operation is applied to all the individual elements, and we're going to need that here in a second. So basically, when you take a NumPy array and you add 1 to it, you add 1 to each of those elements here. And this is what we need to do for our example here. What we want to do in general here is we want to make an animation of these values changing. And for that animation, what you need to do is you don't want to jump from one value to another one. You don't want to jump from 0.5 to 0.4 without a smooth transition. You don't want to be here and then to jump here in the visualization, then to jump lower and higher again and lower. You want to have a smooth transition that you go up and down with. So you don't want to have this jumping effect. You want to have a smooth professional transition. And for that, of course, we need to generate values that are not here. So we need to say if we go from 0.5 down to 0.4, we don't go from 0.5 to 0.4, we go from 0.5 to 0.49, then to 0.48, 0.47. And you can even make this more granular to take smaller steps down so that you have an even smoother animation. You of course need to balance this with the speed of the animation. You don't want to wait too long to get from one year to the next year, for example, or from one time section to another time section, whatever the interval is here. But this is the idea. We want to generate steps. We want to generate data that is not part of the data set. We want to generate in-between data, if you want to call it that. And first of all, we want to create a list of years that all these rows belong to. And for that, we're going to say here years equals 2010 plus I for I in range. And those are 8 rows. So we're going to say here range 8. So that we have a couple of years that those rows belong to. And then what we're going to do is we're going to create this array that is going to have our in-between values, our plot steps, if you want to call it that. So we're going to say plot steps equals np array, and we're going to initialize that array with the first element of the shares array. So we're going to say here a list is going to be passed that contains shares 0. And the reason we pass a list here is because we want to have the proper dimensions already. This array should have a list of rows, so we pass a list with 1 row so that we have the proper dimensions so that we can append to that list later on. Alternatively, you could also use the empty function or something like that and just specify the shape, but we're going to do it like that. And also we want to have this variable here called last shares. This is going to have the previous row, so we're going to say here shares equals 0. And the reason we want to have this is because we want to calculate a difference. We want to have this row here, and this is the next row, and we want to know, okay, what's the difference between this row here and this row? We need to take this row and subtract this row from it so that we know, okay, what changes from this row to this row, and then we know what the step size is if we divide that thing by 100, 1,000, or just 10, whatever you want to have, whatever granularity you want to have, but this is the basic idea here. And for that, we're going to say now for I in range 1 and length shares. The reason we choose 1 here is because we already have 0. So we want to compare 1 to 0. We want to compare this row to this row. And because of that, now we say that the differences are going to be shares I minus the last shares. So this is what has to change. And we can now say differences divided equals 100, for example. So that we know, okay, those are the step sizes that we need to take for the individual positions in the individual rows. So once we have that, we just need to apply that. We need to say for j in range, and we're going to choose the same number here, so 100. If we choose 100 here, we need to choose 100 here. If we choose 1,000 here or 50 here, we need to choose the same number down here as well, because here we have the step sizes and here we have how many steps we take, and they should be related to each other. So if we have if the step is 1 and you divide the step by 100, so you have 100 values, you also want to, or 100th of a step, you want to take 100 steps so that you have 1 full step, right? I think it makes sense. And then what we're going to do here is we're going to say plot steps is equal to np append, and we're going to append to the plot steps array the last shares plus the differences times j. So we take that point that we had before and we move 1 such tiny step size times whatever we are here. So if we have 100 here, this is going to cancel out. 100 times 100 times something divided by 100 is that something. And before we reach that point, we're going to get closer and closer and closer to that point. So in the end, we're going to have the actual value. And before that, we're not going to have the actual value. We're going to get closer to that value. Now, I'm not sure if it wouldn't make sense to actually have this to be 101, because I think that otherwise you never get to the actual value. So I'm going to change that, even though in my prepare code I have 100, but I'm going to try 101 because I think it makes more sense, since when we define that a range is 101, it doesn't include 101. but it includes 100. Whereas if we say range 100, it's only going to include up to 99. So then the last thing that we need to do here is we need to say last shares is going to be equal to shares I, so that in the next iteration, we have 1 for last shares and 2 for shares I, right? So we can take a look at that. We can print the plot steps, and you can see that we have I know why the problem is. What the problem is, we need to provide the axis here. We need to set a 0 here in the end, because otherwise we're not adding rows, we're just adding values. So it's very important when you call the append function that you actually provide the 0 in the end here, so that we know that we're adding rows. And if we do that, you can now see that we have individual rows for the individual steps. So we start with this step here, then this is the next step, and so on and so forth. And we move towards the next row. Having all that, we now can move on to the actual visualization. This is quite simple. We're going to say that years is going to be an iterator over the years list. And we're going to say that the year is going to be the next value from that iterator. And then we're going to say for I and step in enumerate plot steps, so that we have an index and the actual step. We're going to say if we have this 100th step here. So if we have a step number, and I need to say equals 0. If we have a step number here that is divisible by 100, we have made one step, and we can change the year. So we can say year equals next years, like that. And then we can do the plotting. And for the plotting, we know that the x limit is never going to be we're never going to need an x value larger than 1, because the maximum value that a company, or a browser in this case, can have is 1, which stands for 100%. And because of that, we're going to say from 0 to 1 is the x limit. And then we're going to say bar h, so horizontal bar. It's going to be the labels and the step that we're currently looking at. And the color is going to be, in this case, we're going to have green, orange, and cyan, like blue basically. And then PLT text is going to be placed at the bottom right. We're going to say 0.8, 0.2 for the coordinates. And we're going to plot here. We're going to write the text year. And we're going to say also that the font size is going to be 14. Then last but not least, we're going to say pause 0.01 seconds. PLT clear figure, and then once all of this is done, PLT show. So that is enough. We can run this, and you can see now how the market shares change. And I think that was it already. No, it was not that already. But you can see how this changes. You can see how the bars move. You can see how the years change. This is the animation of the artificial example of the artificial data set. So let's recap the code real quick before we move on to the actual data set, to the actual real data set provided by the World Bank. We have labels, we have shares for each row, and one row represents 1 year. We have the year values, and here we create now steps in between the individual rows, individual years. We do that by saying we initialize the plot steps array with the right shape by passing a list of the first row here. And then we store the last shares here in this variable. So the last shares that we looked at, we calculate the differences. We determine how granular we want to have the step size. In this case, we take 100 steps for 1 year. And we basically say, okay, one step has a certain size. We divide that size by 100, and we take 100 such steps in order to get to our goal. Then we reiterate that process all the time until we have all rows done. And then we basically just visualize the individual steps. So now we're going to move on to an actual real-world example by looking at the data provided by the World Bank on GDP per capita by country over the years. And if you want to have that same data set, you can go to the World Bank website, or you can just Google World Bank GDP per capita data set. And here on the right, you can see that we can download the CSV file. I have done so already. And this here is the CSV file displayed in PyCharm. Now, one thing that is important here is you need to remove the first couple of lines, because the original CSV file has, I think at the top, description, date, and maybe a title or something like that, and some blank lines. The first line you want to have in your CSV file is this one here with country name, country code, indicator name, and so on. And then you want to have the actual data. Everything above that is useless for our purposes. And also Pandas is not going to be able to recognize the CSV file as a data frame because of those additional lines at the top. So speaking of Pandas, we also need to install Pandas. So we're going to open up a command line and we're going to type pip install Pandas. And once you have that, you can say import pandas as pd. And then we can load the data frame by saying pd read csv gdp.csv. And we need to, of course, print this to see something. And you can see now here we have the country name. This is a column. We have the country code, and then we have the individual years. Now we can also see that the years are starting from 1960. So we can actually generate here a list of years. We can say years equals, we're going to use strings. So we have the column names then 100, or not 100, 1960. Plus I for I in range, and in this case we want to go to 2020, so we need to provide 61 because the 60 is not included. If we just provide 60, that is that. Let's see if that worked. This gives us from 1960 to 2020. That's perfect. And we also want to specify which countries we are interested in, because we're not going to look at all countries. This would be huge. And also for a lot of countries, data is missing. So we want to focus on major countries that are definitely represented in the data set sufficiently. And we also want to focus on just a few of them. So I'm going to focus here on countries equals, I'm going to say United States, Canada, Germany, France, Italy. I'm going to also go with Austria, which is the country I'm from, and Spain, for example. So those are the countries that we want to use. So we're going to filter for those countries. We're going to say now that the data frame is dataframe.query, and we're going to write the following query here in quotations. We're going to say backtick, and we're going to have two backticks here. The country name, this is the column name, has to be equal to @countries, and @countries refers to this list here. And if we do that and we print the data frame, we should be able to see that only these countries are now represented in the data frame anymore. So all the other countries are not part of the data frame anymore. This is what we want to be working with. Next, we're going to say countries equals df country name, so that we have the series of the column of the country name column here stored in the countries variable. So now we have a series, and we also have the correct order from the data frame. And then what we're going to do is we're going to say that the data frame is going to be the country name plus all the years. So everything that we have here, this is why we had this as a string, so that we can select the individual years columns. We're going to have that, and we're going to drop everything that is a nan, and we're going to provide the axis one. So we're going to drop all the columns that have nan values. So we only want to have years where all the values are available. If some value is missing in some of the columns, we don't want to have it. So we drop the full column so that we have a smooth transition. We don't have any missing values. And this is what this command does. So now we have this data frame. We're going to lose a couple of years, especially the early years. But then I think from 1997 or something, we're going to have everything until 2020. And then what we're going to do is we're going to create a new NumPy array by saying data equals mp empty. And the shape that we provide here is 1 and then 7, because we have 7 countries here. Now, if you have 8 countries, you provide 8. So 1, 8. If you have 2, 1, 2, whatever, you want to have here the amount of countries. You can also specify len countries if you want to. And then what we're going to do is we're going to say for year in data frame columns starting from the second column, because of course we don't want to have the country name and all the other columns are years. For year in the data frame columns, so for the years that are still here after we filtered out all the nan values, we're going to say that the data is going to be np append to the data. We're going to append df that particular year to numpy So we're going to turn all the values from that year to a NumPy array, and we're going to append it here axis 0, so we have the rows. If we now print that, you're going to see what this is. We now have a NumPy array with the GDP per capita for each year for the 7 countries. And now we do the same thing that we did before. So this is, we now have, this is now our shares list. From the example before, this is now the shares list, the shares NumPy array, and we now just need to create the plot steps for that array. Right, so what we do here now is we say plot steps. This is the exact same procedure. Plot steps equals np array, initialize with data 0, same as shares 0 before. And then we say last GDP is equal to data 0. And then we say for I in range, starting at 1, going up until length of data. We're going to say that the differences are data at index I minus the last GDP. And then we're going to say differences divided equals 100. And then we're going to say for j in range 100. We're going to say that the plot steps are equal to np append to the plot steps. We're going to append now the last GDP plus the differences times j, so that we have these individual steps. And again, don't forget axis 0 to add individual lists per row. And then we're going to say just last GDP is going to be data I. This is the exact same loop, just that now we have last GDP instead of last shares and data instead of shares. This is the exact same code. So what we do next is we go for the plotting, and for that we're going to define some colors so that we just have some pleasant colors to look at for the individual countries. We're going to say FF5555. We're going to say 55 FF55. I just prepared some colors here that I think look good. Then 5555FF. Then 55CCFF. We need 7 colors because we have 7 countries. FFAA55. FF55FF. And then finally FFDD33. All right. And now, last but not least, we do the plotting itself. So we say the years are the iterator over df columns starting from 1, because we only want to iterate over the columns that are still there. So not the years that we don't have anymore. And then we want to say for I step in enumerate plot steps. We're going to say if I modulo 100 equals 0. We're going to say try year equals next year. The try is because we can't get the stop iteration error. So we're going to say here except stop iteration. In this case, we're just going to pass. So this is years, not year. And then what we do is we say, this is now a little bit more complicated, because what I want to do here for this visualization, we didn't do that for the previous one, is when 2 bars are equally long, or one is below the other one. And then the one that is below the other one gains value and basically has now a larger bar than the previous one. We want that bar to move up in the graph. So we want the bars to change positions based on their length. We want to have a sorted bar chart, if you want to put it that way. And because of that, we need to copy, we need to first sort the actual steps, and we need to then sort also respectively the colors, because we want to have the same colors for the individual countries, and we also want to sort the country names. So we don't want the bar just to move in the plot. We also want the labels to move, and we want the colors to change respectively so that we have a nice effect. And for that, what we do is we say list underscore sorted is going to be equal to step.copy. List sorted is going to be sorted here. And we're going to then say list underscore index is going to be an empty list. So the idea is that we sort the steps themselves, and then we also want to know the indices. How did the indices of the colors and the names change, so that we can also rearrange those properly, because we don't want to sort the colors, because that's not the same as sorting the values. We don't want to create a new order in the colors array. We want to have the same order as in the step array. So this is the only thing that we sort, and then based on those index changes, we want to also change the order of the other lists. So list index is going to be an empty list, and then we're going to say for x in list sorted we're going to say list index dot insert 0 list step dot index x. So that gets the job done here. This is giving us the indices, telling us, okay, at which position is the original element, or how did the original position change? What is the new index in the new sorted list now of this element? And what we want to do with that is we then want to say that the country names are the data frame country name series, and we want to say that we want to turn this into NumPy. And we also want to say the same thing for the colors, but first of all, we want to order this country names list. So we want to take that list and order it based on this list index list. So we're going to say ordered names is equal to country names I for I in list index. And we want to have also the ordered colors. And this is going to be colors I for I in list index. And all we need to do now is we need to call the matplotlib commands, plt title GDP per capita, plt bar h, and we're going to pass here ordered names. We're going to reverse that. Otherwise, we're going to have the reverse order. We're going to reverse the ordered names. We're going to keep the list sorted in the ordinary sorted way, so without reversing it. And then we're going to say color equals ordered colors and reverse this one as well. Then plt text, we're going to have the year displayed as well at the position 50,000, because 70,000 is going to be the maximum value that we're going to allow for the x-axis. So 50,000 is going to be the position, 0.2 is going to be the y position, and we're going to plot the year. The font size is going to be 18. I'm not even sure if that keyword has an effect, to be honest, but let's forget about this. plt xlim is going to be from 0 to 70,000 as already mentioned. Then we're going to pause for 0.001 seconds, and then we're going to say plt clear figure, and in the end plt show. That is it. If we didn't make any mistakes, this should now work. And it actually does. So we can see that the countries are increasing in the beginning quite fast, and then it takes some more time. Then we have just some minor changes here, but we can see United States is at the top. You can see that the order changed now between Canada and Austria. So they flipped the places, and Austria and Canada flipped, and also the colors flipped. Now they flipped again. So this is the effect that I was talking about. We also want to rearrange the colors and the labels, because otherwise nothing would happen if we just sort the values. So then the bars would have the descending size here, but we wouldn't have the correct labels at the correct bars. So you can see how this works. We have countries growing faster, growing slower, changing positions and all that. But this is how you do such bar chart animations in Python using Matplotlib. So that's it for today's video. I hope you enjoyed it and I hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in our next video, and